So first of all, yes, I would like to thank you, Elaena, and to all the other organizers to make that possible to speak today. I'm always happy to speak at these events, and I'm always saying like one of the advantages of these crazy times is that this is actually possible. And although flying over to LA is also not bad at all. So yeah, thank you very much. And I also like to address also one more time about the sponsors, about the importance of it, because I organize usually the similar Saturday in Munich in Germany. I've done that for 3 times now, and without the sponsors, such a thing is simply not even possible to have this. So also personally from me, thank you to the sponsors, which is actually half of the sponsors that was on the slide is also the sponsors that we had in Germany 2 years ago. So I'm really happy with that. All right, so I will introduce myself quickly. So I am located in Munich in Germany. It's 7:15 in the evening already. I am a team lead at the Metrics Consulting Group. I have a small slide, the next slide, about a little introduction about that. And I've been into SQL Server BI since around 2008, so for quite a while now. A past member since 2004, and I'm the chapter leader of Bavaria, Germany, for PAS, which actually PAS continued to in Germany to operate normally, since in Germany we are a registered community in Germany itself. So the end of PAS Global was not so hard on us, so to say. A little fun fact: I almost booked a trip to the wrong city for SQL Saturday. I was supposed to be on a business trip to Columbus, Ohio, and signed up to speak at a SQL Saturday in Columbus. That turned out to be Columbus, Georgia. I did go though. All right. Why doesn't it go? Okay. Little few words about where I work to give you an idea of also with the content of why the lightning speed processing is so important for us. The Metrics is the leading provider in Germany for marketing automation and campaign management. So we use data which is used to analyze customer data, send out newsletters, push notifications. These kind of things are typical projects that we do with our customers. And yeah, it says over 18 years of experience. It's in the meantime, we're this year is our 20th anniversary, so there's quite some experience that we have there at 4 different locations in Germany. All right, so what does this session look like, or how does it look like? I have a few slides just at the beginning, because the most important part, obviously, is to see how things work. I have set this session up as a result of a business case that I had at a customer, where I thought at the beginning of this case I was not so deeply into the whole partitioning and indexing topic. Throughout the project, I learned so much that I decided, okay, I can easily create a session out of this. So that's where I take a small part of this business case as the topic. I'll tell you what where I scoped it down to make it actually also enough for an hour session, not to make it too much. For those of you, I have a little 2 slides of theory about the partitioning and indexes. If you have been working with it also for a while, it never hurts to hear that one more time. To go a little bit back to the basics about how you use partitions and indexes, or what it actually is. And then I'll jump into the demo. So the business case, It's an on-premise SQL Server environment, and the customer is a large telecom customer here in Germany. They have to process 60 million new records per day. These are records about call data, every phone call that is made, every message that's been sent, chunks of data that's been sent here and there, all anonymized and all that. But we're talking about 60 million new records per day. Or every day, 60 million records are added. And what we needed to do there is we needed to keep 2 months of data on fast storage so other departments were able to analyze that, and the rest of the data, more used for historical purposes, needed to be put on slow storage. With such an amount of data, it's obviously important to focus on that, not to put everything in just one or two disks, because capacity runs out pretty quickly. What will I simulate here in this session? And this is actually a small part of the whole thing. What I'm simulating is actually these moving this data from this fast storage to the slow storage, because these 2 months that I just mentioned is rolling. It's a rolling 2 months. We're in June now. That means the data from May and June. It's also it's current month and last month. So that's the 2 months that I meant. So every month is rolling. Right now, we need to keep June and May on the fast storage. April can be on slow. Next month, we have July, so May needs to be moved to slow. So we're talking about the monthly cutover process to move this data from this fast storage to this slow storage. And the big question here is how to make use of this of the partitioning capabilities of SQL Server. And the one thing that we started with in the project is simply said copying the data over from this fast to the slow storage, and say okay, and then delete that from the fast storage. That was actually, there was no chance that we were able to do that. That we were able to keep that up. Really, no chance. A statement like that would run for over 2 days. So we needed to come up with the method to actually not having to delete this, or not using this delete statement, because that was never ever going to work. And I'll show you how. What I'm actually what I left out of scope is the computing power and storage capacity, because the demo is what I've built on my local laptop. I've created the demo with 1 million data rows, so just a chunk of it, just also to not having to wait a couple of minutes for each statement to run. But I'll tell you which statements can run a little faster, which statements are instantly. And some statements, it doesn't matter if it's 1 million rows or 60 million rows or 100 billion rows. Storage capacity, I also left that out of scope, because we were fortunate to have enough storage capacity. And as you will see, it's also that I will duplicate data here and there. So basically, for some chunks of data, you need to have this data duplicated, and obviously you need to have that storage capacity available. So I left it out of scope, assuming that there's enough. Okay, so the main topics that are involved are different tables, partition scheme and functions, and indices. That's what this all going to be executed with. So before I dive into the demo, just a quick intro or recap in case you're already working on it, to show you what are the partitions and what are indices. An index is basically a pointer to a table to tell that you where you make it easier for SQL Server to find data by indexing your data. Basically the same thing. I have it here also, where you have it at the back of a book, where you can find on which page you can find which keywords. The idea of indexing is exactly the same as in a book. How SQL Server works with it. It has different descriptions here, and in your case, different columns, different data, and you basically save the pointers to tell, okay, this is where you can find that part of the data, this is where you can find that part. Partitions is actually where you are physically dividing your data, where you say, I have a partition of data here where data is stored in the table, and I have an n number of partitions where you define where the data is. Usually this goes by date. We're also using we will also be using the date, so daytime or month or days, where you divide your partitions. And one thing to actually that is really important also in this, what comes back into this demo, is that a partition defines a structure that you tell where your data is. A partition itself does not contain the data, but you're actually telling SQL Server, okay, I have partition X here, and the data of this partition X is in this table on this disk. We will actually see that we're moving partitions around without even touching the data, that the data is physically staying there. We'll see that in the demo. So here, this is the main differences between the two. Partitions is dividing your data. Indexes is sorting and telling SQL Server where the data within the tables is. All right, so as I already said, in the business case, we're using the example data set. And the example data set initially looks like the illustration here on the top, where I have April, May, and June stored on fast storage. I've marked this here with this red rectangle here, that data is located on fast storage. So today we have June 12th, and today we're going to do a monthly cutover, where the end scenario is that all the April data does not have daily partitions anymore, but all in one partition on the yellow on slow storage. So what you see here is from April 1st to June 12th, or even further, we have partitions by day. From all the data before that, it's partitions by month. And the only thing we want to do is merging these 31 partitions into one partition, and also move that data to slow storage. All right. I see here in the chat that is any other slide shared. I'm only seeing about me. Does everyone see this slide down about the example data set and partitions? Okay.
Yeah, it sounds like it's only that one attendee. So if you're having issues, you may want to try disconnecting and reconnecting again and see if that helps out.
Okay, it seems like the majority is for the majority is working. Yeah. Slides and demos, yes, will be shared afterwards. Okay, with that, I will jump right into the demo. And for the demo, I am using the database, the Wild World Importers database, the demo database from Microsoft, and I'm only actually using one table of it, the sales orders. I've copied that, the sales orders, into a sales orders part table, and I've also filled that table with some data. And it's all dummy data. I can actually, since Redgate is also the sponsor of the event, I've used the Redgate data generator to fill this. And it's basically tables with orders. And the most important part that we're going to use is here, order date. And I've added an order date integer, which is nothing else than an integer value of the order date. Why did I do that? For our demo, with this 1 million rows that this table contains, we won't see a difference. But with the 60 million tables, or 60 million rows that are there each day, we actually noticed that indexing and partitioning on an integer value is more has better performance than on the date value. So if you're considering doing that, you might want to consider also using integer value for dates. So this is the main table we're going to use. First of all, what I'm going to show here is the database itself, how this database is stored. As I said, I have used the database, or I have this all set up on my local laptop. But still, the idea, I can show the idea of how you use that with different kinds of storage and locations. I'm using here, I'm looking at the master, at the files, at the file structure of this database. And we see 3 file groups here: primary, user data, and some in-memory data file group. Third one is, we're not going to use that. That's something that with restoring this database, it was actually there. I'm actually not sure what it's used for. We're going to ignore that for now. We are going to use the primary data, primary file group, and user data file group. And you see a location here. On my local laptop, it's both in the standard SQL Server data folder, the MDF file, and the NDF file. And this is exactly where this slow storage and fast storage is divided. I have defined my fast storage in my primary file group and my slow storage in user data. So in the real life scenario, this location would be completely something else. That's how you divide that then. Okay, so that's the structure of the database. First of all, I'm going to look here. I have a query here. It's a pretty long query. I'm not going to go through it, but this is a query I'm going to use a couple of times throughout the demo. And it shows the partition structure of a certain table. In this case, in this sales scheme, orders part table, I'm going to use this to show how the partitions, how they are merged, where they're located, how many rows are in there. But when I execute this right now, there's nothing in there. There's no partitions in this table. So what am I going to do first? I need to create 2 things, a partition function and a partition scheme. And these partition function and scheme, those are 2 things in SQL Server that always work together. And the partition function, that is actually, I can actually already execute this, and then I'll explain what I've done here, because it also prints out the statements. First of all, I need to create a partition functions. What does that do? It defines the boundaries of the partitions. What I'm doing there is telling here, well, how are these partitions defined? By month here and by day as of April 1st. So I go back here, it says create partition function as range right, 4 values, and then it goes here. I just defined a date, 2019, October 1st, and then somewhere here, it's March 1st, April 1st, and then as of April 1st, it actually goes by day. Then it goes April 2nd, April 3rd, etc., up until tomorrow. Important also to know there's a range right and there's a range left, because you say you define boundaries, and within this month, because I'm using the first of the month, then you can actually think, okay, you define the boundaries by the first, but where does the first then belong to? Does it belong to October in this case, or does it belong to September? Is it including or excluding? In this case, I say you have to define right or left. And in this case, I say right. That means what you define is I always, when I don't remember what it was, I always say the value that I select, everything else comes to the right in this case. That means as of 1st of October until the next boundary. If you start using it and you don't remember, just Google it and you can find enough blog articles about it. So the first part is partition function. What are the boundaries? That's where we define the top here. Second part is a partition scheme. And a partition scheme is where you say, where does that data need to be located? And what I wanted is here up until March on the slow storage, and from April onwards on fast storage. That means I need to say, I need to repeat user data lots of times, and as of that, primary. Why do I need to do that? Because these parameters here, or entries, need to be exactly the same as in the function above. If I leave out one primary here, then it will throw an error and say there's not enough, there's more boundaries in the function than what you're trying to create in the scheme. The script that I used above here is actually to dynamically create this script. So for these purposes, I will not go into that so deeply, because I will share also the script so you can also look at it yourself. I've added comments, so if you look at it, then you can find it there. Okay, so in this case, I have created the partition function and I have created the partition scheme, and you can find these under your server and then storage, partition functions, partition schemes. Also, if you're using Management Studio, it's also in the same structure. This is also a one-time thing with setting that up. When I look at that table, that orders part table that I'm using, and I execute this, there's still nothing in there, because the only thing I did was creating this partition function and scheme. There's nothing, no connection to a table yet. That comes here in the next part. In the next part, I actually create an index on this table. This is a standard index. Basically, this part here, that's a standard command for creating the index on this table. So I do this in this order date integer column. And what I add here is this part here on PS order date int. This is where I say, okay, I want to create this index and use this partition scheme. I think I was in the wrong box. Yep. So I execute this. This is actually something that could take a little longer if you have more data, but we're not talking about hours. We're really talking about probably depending on the amount of data, for example, but in this case, 9 seconds for 1 million rows. And now there's actually something to see here. So when I refresh this, then I see the partitions. It's all under the same index here in this column. And this column now has 93 partitions. All the partitions are numbered. And the most interesting part here is the left value and right value. We see here left value, 2019, October 1st until 2019, November 1st. So this goes by month. This goes all by month up until 2104 here, April 1st. And as of April 1st, it goes into April 2nd, April 2nd, April 3rd, etc. So it goes by day. You also see here the amount of rows, about roughly 45,000 here per month. And here it goes per day. That's obviously then a lot less. And also the file group. Up until the monthly partitions, it's in file group user data. And as of that, it's in primary. Yes, I will answer this question about, is there a limit of number of partitions? There is, and there is also a limit on the number of partitions depending on your SQL Server version. I also don't know the exact details, but Elaena, you're right. It's in these kind of numbers, like in the 15, 16,000 partitions or something like that. So what happens then basically in the beginning and in the end? There needs to be a first partition, there needs to be a last partition. And it says null to 2019, October 1st. By defining these boundaries in the partition function, the first one that I used was 2019, October 1st. So what happens is automatically everything that's before that is all packed into this first partition. As you see here, there's more rows in here. So this is the starting situation right now with the table partitioned. Okay, I'll go back to my code, and I have here different steps. This is not going. I'm not going to execute this because this is to unpartition it again, to reset the test, to remove that index again, and there are basically 5 steps we're going to do here. And I'm going through all these steps, and all these steps are also in this script referenced here in this MD text. So when you do that, when you're working with that, also with my demo data, then you can always refer back to these steps, also substeps 1A, 1B, refer to the steps that I have defined here. I also include this Excel file in the downloads. Okay. Step 1. This is actually something from the data. You actually read this from bottom to top. So so time-wise, you read this from bottom to top, 2019, then to 2021. Also, one hint: if you're using this Excel file to also test around with this, I'll be happy to hear about it. You can also hear example date. You can use this to just put a date, first of the month, July, and everything else. Just if you want to practice with it as well, how this works throughout these steps. So this is our starting situation again. All the data in slow storage up until March, fast storage from April on a daily basis. And this then goes further until today. And what we're going to do is create a merge table on slow storage. And this merge table contains all the data from April on the slow storage. So that will be step one. I have here creation of the table. This table needs to be exactly the same as the original table, also with the nulls, not nulls, etc. That needs to be exactly the same. And important here on the bottom on user data. I need to put that there. Okay, obviously creating a table is instantly. And the second step, or second sub-step in this case, is move that data from the daily partitions into the other table, into the merge table. And this is basically moving that, physically also moving that data. Basically what's happening here is I define a range from and a range to. And in this case, April 1st until April 30th. And I loop through that to insert that into my merge table. Why did I do that this way? Also because when the load is getting larger and larger, you can decide to actually do this on a daily basis. This does not need to be on a monthly basis. Because I'm looping through the days, you can decide actually to move a chunk of data each day. Okay, I'm executing this, and also does not take a lot of time. As I said, it's only 1 million, so 1,430, or about roughly 1,500 rows per day. And it basically copies that data into the merge table. Just as a check. There it is, per day, order date, and from April 1st to April 30th. Yep, that's all good. So basically we have this scenario right now. Second step is merging the partition function. Basically what I'm doing here is this partition function where I said April contains 30 partitions. I want to merge that into one partition. I have the data here in two tables, in the merge table, or actually here, I have it in the merge table and I have it in the main table. Merging the partition functions though, I only need to do that once. And why? Because the partition function is irrelevant from the table. It's not that every table has their partition function differently defined. So if you change the function, it changes the structure or changes the partitions for all the tables that are based on this function. This is something also similar here, going through all these dates. So I define my range from, I define my range to. For every partition, I'm basically just firing off this statement. Alter the function and merge the range. Let's just execute that. And this is also done instantly. Also with large chunks of data, this is done instantly. And the reason behind that is also because no physical data needs to be moved. You basically merge these functions together. And merging these functions It does have a couple of prerequisites, because you cannot say, like, I want to merge the partition with one partition located on secondary and one partition located in primary. Just merge those together. You'll get an error. It needs to be the same file group. Table structure needs to be the same, etc. But then there's no physical movement of data, so it happens instantly. Okay, so I'm just checking my partition overview again. And what has changed? Here on the bottom, I go to April. It's partition number 20 that has changed. The left value, the left boundary, is now April 1st, and the right boundary is May 1st. And then it goes May 1st, May 2nd, May 2nd, May 3rd, etc. So what we have reached is this part to merge these 30, and this should be 30, of course, with April, has been merged to all. Should actually go to this overview. That I have one partition for April. And the merge table has that too, because the merge table is also uses this partition function. So the merge table automatically also has just one partition. What we've not done yet is having this data on slow storage, because this partition now contains also roughly these 45,000 rows, but it's still located on primary. And our end goal is to have this on user data. Again, not having to use inserts and delete on the other side. This is where I go back, go here. Step 3, delete from fast storage. And this is where I actually need a third table. And this is also the reason why I said at the beginning that, for example, storage is not an issue in this case, because right now I'm going to move 1 month of data for a third time. What am I doing here? I want to take this out. I want to take what's here. I want to take that out and make sure that the data from the merge table is going to be in there. But as I said, without any deletion, using any delete statement. So what am I going to do? I'm going to create a temporary table. Again, with exactly the same definition as the merge table, exactly the same definition as the main table. Creation is obviously instantly. And here I'm going to switch the partition to the temp table. I search for my boundary. I set my partition ID. So I need to find actually which partition I need to switch over. And then in the end, I say alter table, and I say switch that partition, that number that I found here, to the temporary table. This is also done instantly. Again, data is not moved here. It seems like data is moved because I basically say, okay, the data that is now in the main table goes to the temp table, means moving data from main to temp. But it's actually not the case. Physically, the data is still where it is, and it stays where it is. In SQL Server, you basically define the data that's located on this disk now belongs to the temp table. And how does that work out in our overview? It basically says here, nothing has changed here with the boundaries. but the amount of rows is now 0 because I told it to switch it over to the temp table. So when I look at the temp table, no, that's not right. The temp table does not actually have the indices. So by switching the partition, I move that data to the temporary table located on primary, because also this is the same thing. Switching the partitions is not allowed between file groups. So I need to switch that to the fast storage, also defined in red here. And then basically from here, I'll go back to my other demo script. I can say just truncate that table or drop. That doesn't matter. I just want to get rid of it. When you're going to play around with this, then make sure you're really using test data, copied it somewhere else, etc. It has happened to me a couple of times that I switched, merged, moved, truncated, etc. And all of a sudden I did a truncate before I did a switch or something like that, and then the data was out of the partition and then gone. So make sure you use the test data for it, or test it out really well that it works. All right, so situation after step 3 is that this one does not exist anymore. Or the partition exists, but there's no data in there anymore. And that means I can actually change the partition and include April into the secondary partition. If I would be doing this step with all that data in it, that takes forever. Or yeah, that's not gonna. That's with such large data sets, that's not gonna work out. Because that actually is an operation where data needs to be moved, because you're basically telling, I want to expand this partition function to slow storage, and I want to reduce that. Okay, reducing is not a problem, but I want to expand that slow storage with the April data. But in this case, we emptied it. There's no data there. So changing this partition function should actually be really fast. And this is also one, or actually in this case, a couple of statements where I merge a range and I split a range. Merging is merging two partitions together, so taking out one boundary. And splitting a partition is add one boundary to it. So just for testing purposes, to find the right partition number or the boundary of it, I printed it here, 1st of April 2021. So that's correct. And that means when I haven't refreshed it yet, when I refresh this, that this partition with the 0 rows should change from primary to user data. Let's have a look. And yep, that's all fine. And also this is an instant action because, as I said, there is no data that needs to be moved. Okay. Last step is the data that's in the merge table that was basically parked there since step 2, I need to move that back into the main table. And now I'm actually allowed to do that because the April partition is also part of the secondary group, and there's no data, so I can merge that in there. Before I do that, I need to put the cluster index on the merge table. Otherwise, I'm not allowed to switch. If I don't do this, I will get an error that the 2 tables that you want to switch the partition, that they don't match, because the merge table also needs to have these index on the partition scheme order date. So I execute that. As you see, on 1 million rows, under a second. And then the last step is then switching that partition into the main table. And this is also, again, no data is moved here. The data was parked into the merge table. It was already there on the secondary partition. So it just needed to be, the pointer from the main table needs to be directed. So that data is part of the main table. Let's have a look at the partition overview again. And that's where I then have partition number 20 in file group user data, and that's where I have the end result. And in the end, don't forget to clean up a little. The merge table is not needed anymore. The temp table is not needed anymore. And when you're completely done with that, it's actually, you could create a clustered index again where you actually don't use the partition scheme. So basically you create an index, but you're not referring to the partition scheme. All right. Before I answer a couple of questions that are in the chat, I'll give you a brief summary of these steps that I've taken. So going back to the slide, what I wanted to reach is basically 2 things. Is from a full month of data that is located in one table on fast storage, defined by the red here, with daily partitions. I wanted to merge that into one partition on the slow storage. So these 2 things needed to be done. First step was to create a merge table and copy the data over. This is the only, or basically the main step where data is physically copied. Either once a month, or it could be actually done on a daily basis if you want to split the workload. Step 2 was merging the partition function. So the function, the partitions do not go by day anymore, but there's one partition for the full month. Step 3 was taking out that partition, or taking out the data from the main table into a temporary table on the fast storage, and basically delete the table or empty the table, so there's room to expand the partition. The next step was partitioning to secondary. So the April partition that was located on the fast storage needed to be part of the secondary file group. Since the data here was empty, since the partition did not contain any data, I could easily do that, execute that, and was done instantly. And as a last step, that data that was located in the merge table, I could just move that over there into that partition. All right. So we've reached that end result, and I have about 7 minutes left, so I will go through some questions. I've seen in the meantime that a couple of questions have come in. Elaena, do you want to name the questions and I can go through them?
I tried to answer some of them as we kind of went along. Someone asked about sub-partitions in SQL Server. I've never heard of any. Can you answer that? So they would like to know if there are sub-partitions in SQL Server like there are in Oracle.
If there are subpartitions, I am actually not familiar with the Oracle world, so I'm not sure how that works. But I've also not heard of any subpartitions in SQL Server.
Okay, and we also had a question on will you be sharing slides?
Yes, for sure. I will put that on a GitHub and share the link.
Great, thank you. And okay, another question. What is the difference between the two types of storage that you are using in your real use case?
The difference between the two types of storage. The fast storage was a Fusion or multiple Fusion IO disks, and the slow storage were actually were SSD disks, and they were actually blazing fast. I've never seen any other projects where also the hardware was blazing fast.
Great, thank you. Okay, next question. I'm gonna try to read this one out. I want to use partitions to do, sorry, nothing keeps scrolling on me, to do reload of weekly data. The tables where partitions switched will be occurring is used by application 24 hours. I can restrict for randomly using a flag column. My question is, can we force partition switch and make it priority and not fail as deadlock victims?
Oh, that's a great question. That's actually multiple questions in one,
Yeah.
I would say. You want to use partitions to do reload of weekly data. The table where partition switch will be occurring is used by the application 24 hours. That's going to be a really tough one, because if it's really if those are tables that are really in use for 24 hours a day, I would actually say you might want to reconsider to to redefine the table structure a little bit, because doing that on really operational tables, I'm actually not sure how that's going to work anyway.
I did do that in one of my applications, and I was able to solve the problem. So let me see if I can locate this user. I may be able to send you the scripts. We tested, we actually have a multi-threaded process writing while partitions are also being split and switched.
Okay.
And it did work. I'm trying to think. I think we did a table lock and a hold. But I will double check. It does do it for like a split second, and it does do the lock, and it reprioritizes all the other operations and makes them wait while that's happening. But I will try to locate whoever posted that question and see if I can send you some code.
Great, thank you. Yeah, we did not have anything to do with that, with the data, with our business case. Yeah.
Would there be any time when we don't have the data available for a query that we are moving to slow partition?
That depends, actually. It doesn't need to be. The data that you're moving to slow partition could be classic delta loads, where you are moving that data around and checking which data you actually already got and which data is the new data. As I explained as well, we started with a monthly process where we took all that data and moved it over to the merge table, and already came to the conclusion that's going to take a chunk of time of this monthly cutover process. So we, as time went along, we moved that by day, and just basically checked based on flags, on dates, to locate the last loaded records, and then continue from there.
I will ask a question if you don't mind.
Sure.
So as you were talking, I thought of a situation. I'm currently working on a project where we are pre-processing a ton of data in a temp table. And I was like, oh my God, what if I just not a materialized table, but a temp table, a real temp table. What if I could just, instead of doing an insert, switch partitions, like switch the entire temp table into the actual final table, my destination table. Is this something I can do?
As long as the as it's on the same file group, has the same structure, etc., then there's certainly something you can do there, because there are a lot of scenarios where the data itself does not need to be moved, because the everything in these partition functions and schemes and the underlying data or metadata that SQL Server contains is nothing else than saying, okay, I have this table, where is my data? And by switching, you could say this data is not part of table A anymore, it's now part of table B.
That's great. That might actually really help. One other question regarding that same thing. So the destination table in my case participates in an indexed view. So as long as my temp table maintains the same kind of indexes as my destination table, is there an impact on the index view? Because that's one of the costlier parts of that whole insert that we had, is kind of the impact to the indexed view. Do you know what happens there?
I'm not sure.
Okay, well, I'll test it out and I'll report back. How's that?
Yep, that sounds great. Actually, Vinay already said, he said, I've done that for one of the table and it worked.
That's awesome. Thank you very much. Great conversation here.
It's a bit of a, I had to get used to that as well. It's a bit of a different mindset to actually think, like, where is the data physically located and how does it really need to be moved? And those are often the expensive parts.
Awesome. This is really great. Any other questions, you guys? I think we're at the end of our session. Is there anything else, Erik, that you'd like to add?
No, so as I said, I will share it on GitHub. I will send the link over so it can be collectively also distributed to the attendees. And I will like to thank you again for having me today.
Thank you. Thank you very much for presenting today. Great presentation.
Thank you.
And it is recorded, and we will be sharing all the information on the material and the location of our recordings. I'll post it again in the chat. I posted it earlier. It's on our YouTube channel, but I'll share it again throughout the day, and you guys keep checking back, but we will also notify you. And thank you very much, Erik. I'm going to go ahead and take over the presentation with our own slide deck. Thank you. Really appreciate your presentation and your time today.
All right. Thank you very much, too. And enjoy the rest of the day.
Thanks.